Whether you're just beginning your exploration midway through your studies or shaping the future as a mentor, this journey is yours. Welcome to the Journey Through Computer Science, a complete walkthrough of what truly shapes a computer science student. We start our journey with the foundation of computer science, the essentials that form every learner's starting point. Our exploration opens with an introduction to computer science, the first window into how computers think. Here, students learn basic programming using languages like Python or C. They write their first algorithms, use flowcharts to visualize logic, and develop computational thinking, the art of breaking complex problems into solvable steps. Discrete math provides the logical backbone of computer science. Students explore propositional logic, set theory, and functions. They also learn formal proof techniques like induction and contradiction, skills essential for algorithm design and theoretical computer science. Understanding how computers work under the hood is vital. Students study binary and hexadecimal number systems, then move into logic gates and how digital circuits come together to form CPUs. This fosters understanding of how code translates into hardware instructions. Students learn calculus and linear algebra, not just for math's sake, but because they're essential in graphics, simulations, and machine learning. Calculus teaches continuous change, while linear algebra handles vectors and matrices. To make things interactive and visual, students explore basic web development. Using HTML, CSS, and JavaScript, they create simple web pages, linking code to real-world output and creativity. Next, we move into the core engine of computer science: systems, logic, and structure. Students learn to organize data using arrays, linked lists, stacks, queues, trees, graphs, and hash tables. These structures are the foundation of efficient computing. Code becomes modular and reusable with object-oriented programming. Students use classes, inheritance, and encapsulation to structure software in a logical, scalable way. Operating systems bridge user applications with hardware. Students explore process management, memory allocation, scheduling, and file systems, understanding the backbone of every computing platform. Students learn sorting, searching, recursion, and algorithmic strategies. They measure efficiency using Big O notation and discover design patterns like divide and conquer or dynamic programming. Networks connect computers around the world. Students study the OSI and TCP/IP models, IP addressing, DNS, routing, and network security basics like firewalls and protocols. With core systems in place, the next step explores the deeper logic and design of computing. Students master SQL, relational data models, and transaction management. They learn to organize and query information efficiently and reliably. From planning to deployment, students follow the software development lifecycle. They practice agile methods, use Git for version control, and learn to test and debug code systematically. Students explore abstract machines like finite automata and Turing machines. They learn about formal languages and fundamental limits of computation, what can and cannot be solved algorithmically. Students are introduced to AI concepts like search algorithms, logical reasoning, and the basics of machine learning such as classification and clustering. Here, students dive deep and apply their learning to modern and emerging technologies. Students explore supervised and unsupervised learning, neural networks, CNNs, and transformers. Applications span image recognition, language processing, and data-driven prediction. They learn cryptographic techniques, secure coding, threat modeling, and network defense, protecting systems from digital attacks. Students build compilers from scratch, learning how programming languages are parsed and translated into executable code. Through hands-on team projects, students design, build, and present real-world software. It's the culmination of their academic journey. They develop resumes, practice interviews, study ethics and law and technology, and explore roles in the tech industry. Beyond the standard curriculum, electives let students specialize and pursue their interests. In game development, students work with engines like Unity and Unreal to bring ideas to life. They learn 2D and 3D graphics, physics simulation, and animation techniques. They also design interactive logic using event systems and game loops. turning gameplay mechanics into functional software. Web and mobile development focuses on real-world user interfaces. Students master full-stack web development, combining front-end design with back-end services. They also explore mobile frameworks like Flutter or React Native and learn how to connect apps to cloud services using APIs and databases. Computer vision gives machines the ability to see. Students study how images are processed, how objects are detected and tracked, and how this is applied in AR, VR, autonomous vehicles, and medical diagnostics. In NLP, students teach machines to understand human language. They work with techniques like tokenization and stemming and explore language models like BERT and GPT. Applications include building chatbots, summarizing texts, and analyzing sentiment in social media or customer feedback. This elective introduces decentralized technologies. Students learn how blockchains work, how smart contracts are written in Solidity, and how to build decentralized apps. From cryptocurrency to supply chain tracking, they explore how trust can be automated. In embedded systems and IoT, students build smart hardware using microcontrollers like Arduino or ESP32. They connect sensors and actuators to collect and react to real-world input. They also explore network protocols that link these devices to the cloud. This elective focuses on understanding and leveraging data. Students learn how to clean and visualize datasets, build machine learning pipelines, and work with large-scale data using tools like Spark and Hadoop. At the frontier of computing, students explore quantum mechanics in code. They learn about qubits and the bizarre principles of superposition and entanglement. They experiment with quantum algorithms and platforms like Qiskit to get hands-on experience with futuristic computation. As we conclude the grand journey through computer science education, there's one last area that ties it all together: tools and soft skills. These are the habits, practices, and mindsets that turn knowledge into impact. Students learn how to use Git to track changes in their code over time. They collaborate with others using branches and pull requests, and they gain confidence knowing they can roll back mistakes and manage software releases efficiently. The command line empowers students to interact directly with their system. They learn to navigate directories, execute programs, and automate workflows using shell scripting. Mastery of the terminal sharpens their productivity and prepares them for server-side development or DevOps. No program works perfectly on the first try, and that's where debugging comes in. Students learn to use breakpoints, watches, and logs to find and fix bugs. They also use profiling tools to measure performance and optimize their code for speed and efficiency. It's not enough to build something great. You have to explain it well. Students develop technical writing skills for documentation, proposals, and reports. They learn how to present ideas clearly, both to fellow engineers and non-technical stakeholders. Most software is built in teams. Students practice teamwork through group projects, code reviews, and pair programming. They experience real workflows using Agile or Scrum and learn to manage time, tasks, and shared responsibilities. To thrive in a fast-paced world, students also learn how to manage themselves. They use to-do lists, Kanban boards, and scheduling tools to stay on track. They develop habits to maintain focus, prevent burnout, and work sustainably. Computer science is more than just coding. It's a rich, structured, and creative field. This journey helps students not only learn, but thrive, innovate, and make a meaningful impact in technology and beyond. Whether you're taking your very first steps deep into your studies or guiding others on their path, this is your compass, your guide, your journey through computer science. It's a rich, structured, and creative field. This grand map helps students not only learn, but thrive, innovate, and make a meaningful impact in technology and beyond.